Hello, my name is Muhammad Aminuddin bin Master. My meeting number is CD170115. So today I will explain about the air conditioning system. So for the introduction, air conditioning is the conditioning of air within a defined space, usually a residence or place of business. Conditioning usually involves heating or cooling, humidifying or dehumidifying, and altering air, thus controlling its moisture level. Conditioning it to provide maximum indoor comfort. An air conditioner transfers heat from the inside of a building where it is not wanted to the air outside. Refri- Refrigerant in the system absorbs the excess heat and pumps through a closed system of piping to the outside core. Due to the heat being removed from the air indoor, thus the indoor area is cool. So air conditioner deal with the thermodynamic properties of moist air, and these properties is used to analyze the condition and the process involving the moisture of air. Basically, the air conditioning system cool the air when the weather is hot. That's all. Thank you.
Hello, my name is Harithya Sekai and my metric number is CD150. So I'm from section 5, group 5A. Now I'll present about the theory and the procedure of the air conditioning systems. In theory, an air conditioner works using a thermodynamic cycle called the refrigeration cycle. It is by changing the pressure and state at the refrigerant to absorb or release heat. The refrigerant absorbs the heat from the home and then it pumps it outside. The airflow over the indoor coils, which contain extremely cold refrigerant, which is coolant. The warmer vaporized refrigerant gets compressed or pressurized to a hot temperature, and the very hot refrigerant flows into the condenser coil where it loses heat to the outdoor air. And lastly, the still warm refrigerant from the outdoor unit needs to get cold. So as you can see, this is the diagram of the refrigeration cycle. And next is the TX diagram of the refrigeration cycle, where from 1 to 2, it is an isotropic compression, and from 2 to 3 is a constant pressure heat rejection in the condenser. And from 3 to 4 is a throttling and an expansion valve. And lastly, from 4 back to 1 is a constant pressure heat addition in the evaporator. So in procedure, we will use this machine, the air conditioning laboratory unit, to apply in these experiments. So in the pre-operation, first the refrigerant are observed using the pressure gauge. During the balance condition, when the system is not activated, the normal pressure should be around 1.45 psi at the suction and the disadvantage discharge. Second, the steam generator water inlet need to be connected to the water source and the water tank are filled with fresh water till it reaches 19 liters. And third, the water reservoir on the wet bulb sensor are filled with distilled water. Fourth, the manometer are set to 0. And fifth, the switch of the steam generator, preheater, reheater, and the compressor are in off mode. And sixth, the thermostat of steam generator, preheat, heater, reheater are adjusted to 0 degrees Celsius. In operation for calculating COP and the enthalpy change rate of air and refrigerant. First, the start button is pressed, And second, the fans are turned on and the speed is adjusted to maximum. Third, the thermostat preheater and reheater is set to 50 to 60 degrees Celsius. Fourth, the preheater is adjusted to 1 kilowatt of power usage and the reheater is adjusted to 0.5 kilowatt of power usage. Six, the compression power is switched on and let it run for 15 minutes. Seven, the data was observed and recorded while the system is running. Eight, after observation complete, the preheater and reheater and compressor are switched off. The fans are let to run for 5 minutes to circulate the air and turn off the whole systems. Next is a procedure for cooling and humidifying process. So the first one is to start the button, and second, the steam generator's thermostat is set to 150 degrees Celsius. The fans are turned on and the speed is adjusted to maximum. The steam generator is adjusted to 5 kilowatt of power usage and leave it for 20 minutes. The data was observed and recorded while the system is running. 6. The system generator are switched off and the thermostat are adjusted to 0 degrees Celsius. And the fans was let to run for 5 minutes to circulate the air and the whole system are turned off. So that's all from me. Thank you.
Okay, my name is Arif Nakiuddin bin Sharuddin, metric number CD170156. Now I will present about the results. So first we look at table 1, pressure and temperature measurement. The measurement point, discharge pressure, the value is 240 psig, suction pressure 56 psig, the before condenser temperature 5A, the value is at 3.5 degrees Celsius, after condenser pressure 6A, 28.7 degrees Celsius, before TXB temperature 7A, 27.1 degrees Celsius, after evaporator temperature 8A, 4.5 degrees Celsius, and finally before compressor temperature 9A, 13.5 degrees Celsius. The value is given in the experiment video. Okay, next look at table 2. Thermodynamic properties of the refrigerant in the system. So the value of the table 2, we calculate in the calculation, then we put in the table. We will look at it later. Okay. The table 3 is humidifying, also given in the experiment video. Inlet A, T1A dry bulb, the valve is 21. T1B wet bulb, the valve is 19. Then after preheater, T2A dry bulb, the valve is 10. T2B wet bulb, the valve is 9. Okay, let's look at the calculation. So discharge pressure of preheated P3 equal to P2, as you can see, we get 254.7. Then the suction pressure at preheated P1 equal to P4, we get 70.7. Then 1 psi equal to 6.8946 kPa. Then P1 equal to P4, we calculate, then we get 0.487 MPa. We can see in the table 2, suction pressure 0.487 MPa. Then for the discharge pressure, P3 equal to P2, we get 1.756 MPa, as you can see in the discharge pressure table. Then we calculate H1. H1, we use the linear equation to calculate the X, which the H1 is at 487.46 kPa, which is between 450 and 500. So we use linear equation, we calculate the value of X, and then we get the value of H1. X is equal to H1, 257, as you can see, 0.9 kJ per kg. Okay. Then we calculate H2 at 1756 kPa. Same, we use linear equation, which is between 1600 and 1800, and we calculate the X value for H, and we get 278.88 kJ per kg for H2, And for H3 is equal to H4 at 1756 kPa. It's the same as H2 between 1600 and 1800. And after we calculate, we get 142.28. And finally, we calculate the COP, which is coefficient of performance. As you can see in the slide, we get 5.51 kJ per kg. And lastly, enthalpy change rate, H1 minus H4, we get 150.62 kJ per kg. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faiz Nur Ashraf bin Hassan, ID 180135. Today I want to talk about the air conditioning observation and discussion. The observation is throughout the experiment, we can see that the air conditioning process are mainly consist of two main processes as a way to keep it fully functioning, which is to cool the temperature inside the confined space. During the experiment, the air flows through the coil due to the suction from the fan, and it will be cooled with the help of refrigerant inside system. When there are absence of hot air flow through the cool air coil operator, the air discharge will be very cold as the temperature at the output is lower. The coil starts to form an ice particle surrounding it, and after the heat are applied to the airflow, it became warmer and the particle at the cold coil begin to melt. The preheater recovers the heat to increase the thermal efficiency by reducing heat loss, and it is also used as a way to remove air content which disturb the air which are being sucked into the system. The reheater can be used to control the ambient temperature as it serves as a function to add heat energy which have been released. Discussion. Throughout the experiment, we can say that the result obtained of suction pressure and discharge pressure were correct, which is 240 and 50 psi respectively, and the enthalpy were obtained from the pH diagram. From all information obtained from the properties table, the COP of the air condition were 5.51 kg over kilogram. The value were greater than 1, which proved the system have higher heat and energy loss than the lesser heat and energy gain. The rate of change of the enthalpy was 115.62, and the moisture air content inside the air is 0.0172. Since the experiment were conducted by staff and lecturer inside the laboratory and being recorded for experiment purpose, we can say that any parallax error and any error can be considered to be neglected and all data obtained are given.
Okay, next I will present about the conclusion. To conclude this, the experiment can be considered successful as students are able to analyze and produce discussion according to the experiment result. Hence, the objective of this experiment is obtained. Although the online learning has not been allowing students to conduct the experiment in the laboratory by themselves, the video recording process is helpful. The procedure to analyze the result are also provided, which allow the student to calculate and analyze the coefficient of performance for the air conditioning system, which is 5.51 kilojoule over kg. This proves that the system experiences more heat energy less than it can obtain. So, thank you.